In this video, we are going to look into hypothesis testing. The objectives of this chapter are to define and set up hypothesis testing, to define the null hypothesis, and to create a hypothesis test to evaluate the null hypothesis. Examples of hypotheses are the following: dropping the salt consumption, lower the blood pressure in hypertension patients. The second, students in this school are above average intelligence. You would imagine that you will have to make a test in which consider different types of students, and you have to prove that hypothesis. An engineer hypothesized that the mean Brinell hardness of certain ductile iron pieces is greater than 170. So the engineer made a test, took a sample of different measurements, and is making this conclusion. So we want to be sure that that conclusion is certain. And the last example is the COVID-19 vaccine is 90% effective. So how do they can publicly say that the vaccine is effective? They in fact have to accomplish a hypothesis testing to come out with this value. Suppose that we are drilling a low carbon alloy steel, and we want to test the lifetime of the micro drill. And so the lifetime is expressed as the number of holes drilled before it actually breaks. So from the test, we have that the mean is 12.68 with a standard deviation of 6.83. Let's assume that the main question is whether or not the population mean lifetime mu is greater than 11. So that will be our hypothesis. So we can address that by examining the value of the sample mean. So if the sample mean greater than 11, well, is 12.68. So there is a chance that the population mean is in the same way. So we see that our sample mean is greater than 11, but because of the uncertainty, it is not guaranteed that the population is going to be greater than 11. It could be just by chance that this sample was greater than 11. So we would like to know how certain we can be that mu is greater than 11. So can we use a confidence interval to test that the mean is greater than 11? Well, in reality, a confidence interval is not quite we need. So the statement mu greater than 11 is the hypothesis in this case, and the hypothesis is about the population mean. Remember, we have a sample, and with the sample we want to get information about the population. So to determine how just certain we can be that the hypothesis is true, we must perform a hypothesis test. Well, although the hypothesis test is not a confidence interval study, it is very related to confidence intervals. How do we accomplish a test for a population mean? First of all, in this section, we are going to assume that we have a large sample. Large, remember, meaning larger than 30 sample elements. So we need to define two hypotheses, the null hypothesis and the alternative hypothesis. So the null hypothesis, which we denote with H0 or H0, says that the effect indicated by the sample is due only to random variation between the sample and the population. So that means that the result that we got were just by chance. The alternative hypothesis says that the effect indicated by the sample is real, that accurately represent the whole population. So remember, we denote the alternative with H1. Most of the cases we are interested to prove the alternative hypothesis, and to prove that we deal with the null hypothesis. Remember, the null hypothesis means that the result that we got, it was a random variation of the sampling. In our microdrills example, we have a sample mean and a standard deviation given by these two values, and we want to look if the population mean is greater than 11. We have that the null hypothesis in this case is the opposite of what we want to prove. So mu is not greater than 11. In other words, mu is less than 11. So let me represent it in a line. So we have mu of the population, and we want this mu equal of 11. So h naught is mu less than 11. And h1, it will be mu greater than 11. This represents h1, and the first part represents h0, or the null hypothesis. And remember, we are looking into get information of the population. Okay, let's summarize. The null hypothesis means no effect or nothing happens, and there is no difference or no relationship. As opposed to the null hypothesis, the alternative hypothesis means that there is an effect, or something happened, or there was a difference. In both cases, we are making a statement about the population, not the sample. The sample is giving us the information of the population, and we just want to know how certain are we of the result of that sample. There are two important things about the hypothesis H0 and H1. One is that they are mutually exclusive, so it's just one or the other, and the second is that they are exhaustive. So there is no possibility different from H0 or H1. There is no third possibility or fourth. So we only have these two possibilities in our test. Let's have a look to an example, and this is related with the Pearson arc correlation. So remember, when we are correlating two variables, so we have x and y variables, so we can have two different results. We can have that the sample that we take, it looks like that, or the sample that we take, it looks like that. So in the second case, we can approximate this like a linear relationship, and we say that the Pearson correlation R is equal to, or approximately equal to 1, while in this first case, R is approximately equal to 0. The null hypothesis, it will say that there is no relationship between the two variables in the population. So this will be the null hypothesis. And the alternative hypothesis is that there is a relationship between the two variables of the population. We begin by assuming that the null hypothesis is true, just as we begin a trial by assuming that the defendant to be innocent. The random sample provides the evidence. The hypothesis test involves measuring the strength of the disagreement between the sample null hypothesis to produce a number between 0 and 1 that we call the p-value. There are similarities with a trial. In a trial, we usually have the accused that is presumed innocent until is proved guilty. In this case, we assume that the null hypothesis is true, and we must prove otherwise. And after that, the verdict will be that either the accused is guilty or not guilty. In the case that is guilty, it's equivalent to say that the null hypothesis is rejected before any reasonable doubt, and the non-guilty means that the null hypothesis is not rejected. The p-value measures the plausibility of the null hypothesis. The smaller the p-value, the stronger the evidence against the null hypothesis. If the p-value is sufficiently small, we might be willing to abandon our assumption that the null hypothesis is true and believe the alternative hypothesis instead. We refer this as rejecting the null hypothesis. So in this plot basically means that if the probability of the p number is small, so we are over here, so we have evidence against the null hypothesis and the alternative hypothesis is true. So we want to be on the tails of our probability distribution function to prove the alternative hypothesis. When we are closer to the mean, that means that that we cannot reject the null hypothesis. These are the steps to test the hypothesis. First of all, we have to define the null and alternative hypothesis. We start by assuming that the null hypothesis is true. We compute a test statistics. That means that we take the sample and we compute the mean and the standard deviation of the sample, and we are going to use that to take information against the null hypothesis. Next, we compute the p-value of the test statistics. The p-value is the probability that the null hypothesis is true. So if the p-value is large, that means that H0, the null hypothesis, is true. And if the p-value is small, so we can reject the null hypothesis and assume that the alternative hypothesis to be true. And finally, we state a conclusion about the strength of the evidence against the null hypothesis. So we can have either the null hypothesis is rejected, means that the alternative hypothesis is true, or we have that the null hypothesis is not rejected and therefore the alternative hypothesis may not be true. In the next video, we are going to have some examples in how to prove the null or the alternative hypothesis.